Aloha, this is Gary LaRude at the Qorvo booth at the 2017 International Microwave Symposium, and I'm here with Dean White. Dean, former colleague, good to see you again.
Good to see you too.
So, all the hype at IMS and certainly through the industry is about 5G, but kind of in the background, not getting a lot of attention. The defense market is growing, and certainly Qorvo is having great success in the defense market. Can you talk a little bit about some of the trends that you're seeing in defense that are fueling your growth?
Yeah, we're seeing a lot of very positive trends in defense. It continues to grow tremendously. Particularly, what's really surprising is how it's growing in lower frequencies, 1.5 gigahertz and below, which is kind of surprising. We're seeing that it's encroaching more and more on those LDMOS, typically LDMOS sockets. But you know, the more traditional, where we see more AESA type radar systems, phased array radar systems, and also customers that are going to broader and broader bands, which GaN, of course, does really well in broadband applications, as well as really high frequency, and that's one place where Qorvo does an excellent job. We have processes that will get you all the way up to 80 gigahertz. So there's a lot of different applications, especially in defense communications at those types of frequencies.
So can you talk about some of the recent products you've introduced kind of targeting these defense applications?
Yeah, so some of the lower power, I mean, one of the things we've seen is that the lower frequency levels is that we've seen a push to higher voltages. So we've released about 14 different 50-volt transistors, and they come in a variety of different ways. One of them is fully matched, 50 ohms in, 50 ohms out, can be all the way up to 500 watts, all the way down to about 7 watts. And some of them are partially matched, some of them are matched on the input, but it's a push to higher voltage, so you can take advantage of higher voltage, less current, less losses across your array or across your system.
And probably easier to match, I assume.
Definitely easier to match, yeah, because we do some of that work for you on the input of the device. The other thing on the MMIC side is really filling in kind of the gaps. You know, Qorvo has a very large portfolio of different MMIC products that cover all the way from DC all the way up to 40 gigahertz right now in their standard product catalog. So we're filling in those gaps, and we're releasing a lot more products from 30 to 40 gigahertz as new processes come online, particularly like our GaN 1.5 thin process. And there's some other processes that would push us even higher that are in research now, up to 80 gigahertz.
That's cool. So even though GaN gives you a lot more power, I know you're doing some more vertically integrated work to try to get to even higher power levels. Can you talk some about that, your Spatium products?
Yeah, Spatium is a real exciting product, and I have an example here of a Spatium product. This is using spatial combining, so you can use GaN amplifiers, use about anything actually. You can use GaAs or GaN, but our GaN on silicon carbide. The great thing about this type of product is that you can combine as broad as the MMIC is. So if you can design a broad, decade, 2-decade wide bandwidth type MMIC, you can put it in a Spatium and you can efficiently combine that with up to 93% or higher combining efficiency across a very broad band. Now this one's quite large. This one is a lower frequency Spatium, so it's quite long and quite large compared to the higher frequency Spatium, which would be about a third this size. Say, this one would be up to about 6 gigahertz. A one that operates at Ka band would be roughly about 3 inches long, but it's all spatial combining. You can pull the heat out around what we call the clamp or the collet. This is the DC biasing. The RF in and RF out ports can either be waveguide or they can be coaxial, like this one is coaxial. But yeah, it comes in a variety of different ways, and it's very popular because it's one of the few ways where you can efficiently combine very broadband MMICs into broadband. It works very well for EW applications and also for comms in replacing TWTs.
So you're having some success taking some of those TWT sockets away?
We're having great success. It feels good to be able to take away some of those slots, and we've been able to beat them out at their own game as far as efficiency over a very broad band. And so that's very exciting for us. Now it's just a matter of producing more and more of them.
And I would think you have a lot better reliability than a TWT.
Yeah, that's the great thing about these is they operate at a much lower voltage than a TWT operates. So if the MMICs inside are at 28 volt, that's all you need is 28 volts in order to be able to bias these MMICs. The other great thing is that it's a graceful type degradation. So let's say out of the 16 MMICs that are in the Spatium, one of those MMICs fails. It's a very there's a whole formula that you go through to determine, but you don't lose that much power overall, whereas a TWT, it's more either on or it's off.
Well, Dean, thank you for giving us an update on the state of the defense market at Qorvo. Some very exciting things going on.
Thank you. It's good talking to you, Gary.
And this is Gary LaRude from the 2017 International Microwave Symposium in Honolulu with my former colleague, Dean White.